Hello everybody, and welcome back to the Blockchain Mathematician, where on this channel we discuss topics all the way from blockchain, how it works, and how it is used in the real world, up to mathematics, physics, science, and much more, such as coding and programming, and using this programming tools to help you learn the aforementioned topics. Alright, let's begin. In today's video, we will be doing a part 2 to a video I've already made on my channel, and if you haven't watched that, I recommend you go and watch it. This video is on proof of work in blockchain, explained simply. So, to begin, what we talked about last time is simple transactions and how they work, and how we can use that and put it into a block. And we will be discussing this topic in further detail. Last video we discussed the index, and we also discussed transaction data, which I will be just writing in the form of data. In today's video, we will be discussing 3 more topics. This includes the hash, the previous hash, which I will be writing in the form of prev, and, last but not least, the knots. Alright, let's begin. So, let's go from the top to the bottom. So to begin, let's explain the hash. Imagine you're just walking on the street, or you're in your house, and you wake up in the morning, and you look outside, and you see someone walking in the street. And you realize that this is someone that you know. And let's say it's your neighbor, or perhaps your sibling. So, let's take this vision that you have as the input data. And what you see will be put into your brain, and your brain will process it. Your brain will process it and then spit out who they think it is. Let's say it's your sister. So what is this? Instead of calling it brain, let's call it a magic box, which I'll be writing in the form of MB. So I'll be erasing the sister piece of information, because this is not useful when it comes to blockchain, and it was just an analogy. So you have input data, and it goes to your brain, and this brain is capable of doing something with this input data and telling you whether it's your sister, let's say your mom, your dad, your neighbor, and etc. But for today's video, we'll be discussing it in the form of blockchain, and how the magic box is capable of spitting out a hash. So we do something with our block, and we put it into the magic box, and we get out the hash. So what piece of information do we already know? That is the index and the data. So let's put that in. So I'm going to write down the index and the transaction data. Index and the transaction data, which I'll just be writing as in the form of data. And yeah, this index and the data are put into the magic box, and this magic box is capable of spitting out something as a hash, which is in the form of bytes. So, what can this hash be used for? Well, imagine you need to recognize something or someone. You'll look at it, and let's say you use your vision, and you're capable of seeing who that person is. In this case, in the form of blocks, this hash will be capable of telling you what is inside of the block, and how to identify each block from each other, the differences from each block. And later on in this video, I will be discussing how this hash is capable of connecting all of the blocks into one blockchain. So, I'll be going on to the previous hash. This previous hash is quite simple now that you understand what the hash is. So, let's say this is another block. It has its own index, has its own data, and it has its own hash, and etc. So, what we can do with this hash is we can realize that the previous block had its own hash, right? And to connect each block together to perform a blockchain, we can do that by using what's called a previous hash. which pretty much indicates to what the previous block in the blockchain's hash was. So in this case, the hash, let's say it was something. I'll put it in the form of the letter A, right? But remember that this A is not the hash, it's just a variable which shows what the hash could be, right? And this previous hash would also be equal to A. It would always be equal. So that means instead of A, I'll be using previous hash. So this hash of the previous block will be equal to the previous hash in this block. Perfect. So what does this do? It's capable of connecting all the blocks together in the blockchain to make sure that it is very valid and secure, and is capable of organizing the data correctly and making sure that there are no mistakes or improper characteristics inside of the blockchain. So moving on, I'll be discussing this nonce as our final topic for today's video. So this nonce is something that goes into more about proof of work. So I'll be beginning to explain what proof of work is. And I'll be deleting this hash. And actually no, I'll be moving it to the side. So just in case any of you need it, you can always look back and understand what this hash is, as we'll be needing it soon. So this nonce, imagine you have a bunch of computers, which I'll be using in the form of shapes. Circle, triangle, and a square. Instead of imagining them as shapes, imagine them as computers. And these computers are all going for one goal. And that is to solve some kind of equation and retrieve what the hash is. So when a transaction is made, these shapes or computers don't know what the hash is. And that's their goal. Their goal is to find what the correct hash is. And once they do, they're capable of receiving a reward in the terms of Bitcoin. BTC is equal to the reward. So, how do these computers do this? Well, the way that these computers are capable of computing what the hash is by using the nonce. And this nonce is just a regular number. So let's come up with a random number, such as 2027. This is a random number that I just came to the top of my head. And what this nonce does, is it's capable of outputting a different hash. But how? So remember, if we go back to this diagram here, we have the index, the data, which are then put into the magic box and spit out the hash. Along with this, we can add one new piece of information, just a random number, or in this case, what we call the nonce. So this index and data plus the nonce are now all put into the magic box, and they output a hash. So let's say we put this nonce to be this 2027. 2027. This would output a different hash than if we were to input the number 2026. And it would also be different than if you were to put it into 2025 and etc. So let's say that the hash is something that the miners are still looking for and are still trying to search for. What they can do is they can input as many of these different nonces as they can, and eventually, if they're capable of outputting the correct hash, that means they get the reward of the Bitcoin. And once they're capable of finding the correct hash, they'll be capable of validating this block and making sure that the transaction was valid and correct. This form of validation is capable of making sure that the blockchain is secure and in a safe and valid blockchain. So, but what are the flaws of proof of work? The flaws of proof of work include the fact that this hash is extremely hard to find, especially for humans. So, many people have begun to use computers. But as people begin to invest more and more and more money into these computers, the more electricity is used and the more electricity is wasted. So, what happened? So now, with Bitcoin, a lot of energy has been used and wasted to the point where the energy used for this Bitcoin mining has overtaken the amount of energy used for countries such as Hungary and so on. Pretty small countries, but also with large populations. And this has been beaten by a different kind of system, and that's proof of stake. We will be talking about that in a future video, as this takes over and uses this disadvantage of proof of work and creates its own system, proof of stake, which does not use as much energy. Therefore, proof of stake, to some people, is a better use of validation in terms of cryptocurrency and blockchain. Thank you very much for watching my video. I hope you enjoyed, and I hope you have an absolutely spectacular day. Thank you.